Welcome back, AAF students. In this video, we're going to start off with a question or two questions that I'm going to ask you. And what I really would like for you to do is to pause the video and try these two, right? So I'm asking, can you simplify? And I'm going to tell you your answer. Your answer is yes. Every single one of you can simplify these. Now do it. So hopefully you've done it. If you haven't, pause the video and actually do it. So what I'm going to do, and I'm just dividing two fractions, right? It's expressed a little bit differently than maybe I saw, but you know how to divide two fractions. So I'm going to rewrite these as 3x over 7. Instead of dividing, I'm going to multiply by the reciprocal, 2x squared over 5. And then I'll go ahead and simplify these, right? And this, when I multiply straight across, we like doing this, is 6x to the third over 35. Right? Pretty cool. What about this one? Right? Instead of me dividing, I'm going to go ahead and say 3x over 7 times 5 over 2x squared. And I can do some simplifying here, right? This x is going to go away, and I'm no longer going to have this as a squared. And then I can multiply. 15 over 14x. I'm curious when you look at this, if you see anything else that I could have done, hypothetically, to just immediately get rid of the denominator, right? So I've got these like fractions within fractions. Ugh. I can't multiply by anything except for one number. I kind of just said it. Anyone know what the number is that I can multiply by? Hopefully you're yelling at the computer right now and you're like, you can multiply by 1. And 1 can take any form that you want. That is your choice, like your prerogative. So I want to multiply, so like this whole thing is my numerator, this whole thing is my denominator. I highlighted, so I kind of chunked it together. And I want to multiply by the number 1 so that I immediately get rid of the denominator. So both denominators, I no longer want a fraction. So was anyone thinking I can multiply by 14x squared over 14x squared? Watch what happens when I do that, because I just multiply straight across. So when I do that, I get 14 times 3, which would give me, just kidding. I have 14 times 3, but then divided by 7. That's just going to give me 6, right? 14 divided by 7 is 2. 2 times 3 is 6. X to the third over what happens here. 14 divided by 2 is 7. X squared goes away. And I just end up with 7 times 5, which is 35. Whoa. I picked a 1 really carefully, right? This is just 1 that got me to get rid of my denominators, my like little denominators. I'm going to refer to them as my minor denominators as we move through this today. Pretty cool. Do you have any idea when I just did that, how I could do it for this one down here? What might I pick my form of 1 to be? And just remember that I have, keep doing that. I wish there was an easier way to get highlighter. I wish I could just say it and it changed to the highlighter. Wouldn't that be cool? One of you guys should invent that. I'm going to pick to multiply by 35 over 35. Right? Multiply this one by 35. That's going to get me, that's going to get me a 15x in the numerator. And then, right, you see how I did that? 3 times 35 divided by 7. 35 divided by 7 is 5. 5 times 3 is 15, and the x goes through. You multiply straight across. This is like 35 over 1. That's the best invisible math. And then over here, I've got 2 times 35 divided by 5. which is just like 7 times 2, which is 14, x squared. And then I can take a look at those x's. And, well, that's going to go away. And I'm going to get rid of one of those. So I'll get 15 over 14x, which is what I got up here. It's another way to simplify instead of me dealing with the reciprocal. How cool, right? When I don't have things that I need to factor in the same way, this might be pretty nice. So what we're going to do today is we're going to use our knowledge of operations, right? Addition, subtraction, multiplication, division are all the things that we know with these operations, with rational expressions, and complex fractions. I wonder what I mean by complex fractions. You just got a taste of it. I will simplify complex fractions with rational expressions. So while this is not really an operation per se, this is simplifying complex fractions is really what we're doing here. Okay, so it embeds kind of the other operations that we talked about. So when I'm saying this word complex fractions, it's what you just saw in the warm-up. That wasn't really a warm-up. In that quick review, I guess it was a warm-up. A complex fraction is like a fraction within a fraction, right? They get complex. That's what I mean by complex fraction. So it's a fraction within a fraction. Now, in the warm-up, we could have used what we knew about division. Sometimes they get a little bit more complicated, and is that the way that you want to approach it? Maybe it is, maybe it isn't. So I'm going to kind of expose you to some other ways that we can deal with complex fractions, but keep in mind that there are other pathways to the correct solution. There is one correct solution, but the pathways to get there can vary. And so I'm going to try to show you a few different ones so that you can see what works best. And it doesn't necessarily mean that you have to pick one and always do it, right? It's beneficial, and this comes with practice, as many things do. As you do more, you start to recognize what might be my best approach. How do I analyze the situation that I'm given and figure out what is the best pathway forward? Oh, that's not even true in math. That's true in everything. Crazy. Okay, so simplify complex fractions. Our goal, our ultimate goal here is no fractions within fractions. Ugh, I've got fractions within fractions here, right? So you have the background knowledge of common denominators, right? So I could sit here and I could give you this problem, and I have no doubts that you guys would persevere through this, and you would get a common denominator in the numerator, and then add them together and simplify, and then you would get a common denominator in the denominator and subtract them and simplify, and then instead of dividing by a fraction, you would multiply by the reciprocal. Not a bad approach, but I want to give you another approach. Okay, so we're going to identify what I'm going to refer to as the minor denominators. It's the little ones, right? So like the x and the x squared. Those are my minor denominators. Okay, I'm going to determine the least common multiple between them, right? And so remember, the least common multiple, the least common multiple of them it can't be x, right? That's not a multiple of x squared, right? Like the least common multiple between 2 and 6 is 6, not 2. That's a factor of 6. It's not a multiple of 6. So it has to be the least common multiple of both of them. Okay, so what is that for this one? Maybe you're thinking it's x squared. And I'm going to multiply both the numerator and denominator by that least common multiple, which is x squared. Okay, so when I do that, I want you to remember that you've got to distribute. I'm going to multiply it to both parts. Right? All I'm doing here is multiplying by 1. I just picked the form I want 1. That's all I did. Right? So multiply every term in the major numerator, and every term in the major denominator by your least common multiple, your LCM. Okay? So when we do that, we get this. Right? Well, what just happened if I now simplify that? What happened? I am eliminating the minor denominator. Goes away. And I now have 12x squared plus 6x over 12x squared minus 3, right? You're immediately eliminating it. You're not like trying to find a common denominator and then adding or subtracting, right? That might not be the fastest pathway forward. It might not be the one that has the least obstructions, where you might have the more opportunities to make errors. Maybe it is. Maybe that is your best pathway. I don't know. I'm just giving you other pathways, right? And now I can proceed forward and simplify this. All right, so I know that my numerator factors into 6x times 2x plus 1. I'm factoring out a common factor, right? And the denominator can factor out a 3. Can actually factor the denominator more, right? Difference of squares. 4x squared, difference of squares. So what now cancels? What simplifies? I'm left with 2x over 2x minus 1, right? So these canceled out, and then 6 divided by 3 is 2. So those canceled out and became a 2. So that's where I've got 2x divided by 2x minus 1. And you're not going to get sloppy and try to cancel. You can't cancel across a minus sign or a plus sign, right? By order of operations, I would need to subtract these before any division could happen. So I can't do anything else. That's it. That's my answer, right? This, what we had started with way back here, this mess is literally just this. How nuts. Okay, so that's just an option. So we're going to do that here. Who needs to be eliminated? We're going to focus in on our minor denominators here. X and x squared. What's the least common multiple? X squared. So I'm going to go ahead and pick something to multiply by, and I'm going to pick x squared over x squared. That's going to get distributed to everything. To everything. And that's going to leave me with x to the third minus 5x squared plus, you know what, I might just take a step forward here, 6x. Okay, no longer have a denominator. Here I'm going to get x squared minus 9. Now let's do some factoring. Okay, I see that I can have a common factor up here, an x. So that's going to give me x squared minus 5x plus 6 over difference of squares, x minus 3 times x plus 3. X times, what does this factor into? X minus 3, x minus 2 over x minus 3, x plus 3. See ya. Those cancel. And then I'm left with, I can't do anything else. Let's expand that, x squared minus 2x over x plus 3. And that is what that simplifies to. Right? Whereas you would have to get a common denominator and then multiply by the reciprocal. It's fine. You can choose that. But here is another option that does some of the work, like using something like I'm just picking a form of 1. That's going to help me out. Okay, you just got to carefully pick that one. And that's a really good skill to have. Okay, can you do it differently? Sure, I'll show you how you can do it differently. Right, so my other option is maybe I would get a common denominator. So I've got x squared over x minus 5x over x plus 6 over x. That should be an x. That's just my numerator. And then this would be x squared over x squared minus 9 over x squared. Okay, so here I've got x squared minus 5x plus 6 all over x divided by x squared minus 9 over x squared. And then I've got, instead of dividing by a fraction, I'm going to multiply by the reciprocal. So you see, like, there's a lot of similarities. So maybe there is times where you want to come up with a common denominator, right? The more practice you have, you can figure out what works best for you. Okay, so let's see now. I'm going to just get rid of this at this point, and then that one. And then I can factor, and I already have done some of this factoring, right? So I'll stick that x out here. So I've got x minus 3, x minus 2 And then in the denominator, when I multiply straight across, I've got x minus 3 times x plus 3. These cancel, and I am left again with x squared minus 2x over x plus 3. So it is a different pathway to the same solution, right? But using some of the things that you know about addition and subtraction of fractions and of rational functions in general. So this is an example of a time that I would personally not want to find a common denominator, right? When you've got it as a binomial, ugh, I don't want to get all of these to have that as a common denominator. That to me makes it messier. So I'm gonna carefully pick. Here's my minor denominators. This is so great when those are my minor denominators because they're the same. I don't even need to worry about it. I'm gonna pick my form of 1 to be x minus 3 over x minus 3. It's got to go to everything. Don't forget, it's gonna go to the x, to the 3, and to the 5. It's gonna go to the x, to the 2, and to this 4. And let's see what we have. Does it come up? Okay, sorry, I thought it came up for some reason. So when I do that, I'm gonna distribute as it happens. X squared minus 3x. That's where when it goes to x. Plus 3x minus 9. I don't need to worry about multiplying the 5 by it because those are just going to cancel. Plus 5. Over x squared minus 3x plus 2x minus 6. So I did x times both of these. 2 times both of these. I could treat it like a binomial if I wanted, but that's what's happening, right? And then when I multiply 4 by that, I don't need to worry about it because the denominator is going to make that cancel. I'll just get a plus 4. Okay, so I really in this numerator have x squared. Those 3x's are going to cancel. Negative 9 plus 5 is minus 4. Okay, I know that I can factor that. X squared minus x minus 2. So this is going to give me x minus 2 times x plus 2. How great my knowledge of factoring is when I do this. X minus 2x plus 1 can cancel because now I've got everything's multiplication and I'm left with x plus 2 over x plus 1. How fun. That rhymes. So I had to say it. Okay? Just expanding your knowledge, adding to your tool bag, right? The different things that you can do. So in this lesson, what we just did was as I just said, we really built on what we already knew about rational expressions and simplifying rational expressions in order to work with complex fractions that involve rational expressions and just giving you another way to simplify and approach a problem that will lead you to the same end goal. Okay, so make sure that you are practicing and using all of your resources and doing all your homework, and we will see you in our next live session.